We're good?
Looks good.
Okay, great. All right, well, thanks. So my background in entomology or in citizen science really began as a doctoral student at UNL, and it's continued through establishing programs here in Nebraska, including the Citizen Scientists of Nebraska Network. I love working with Allie Mays on that and our core group. I've worked on other entomology related projects and soon continued research on participant outcomes of these programs. So in this presentation, I'm going to introduce the concept of data validation, why it's important for both researchers and for citizen scientists. I'll introduce a few different types or examples of data validation, and there's a lot of different ways to crack that nut. And then I'm going to share some resources that I think are particularly valuable, and that'll probably be the most valuable part of the presentation for you. And then we'll close on opening the floor with some questions. So we've highlighted, I think, pretty well today what citizen science is today, and what I want to highlight here are the relationships. There are a lot of people that are involved in citizen science, and it could be the social science leanings that I have, but I think these relationships are really important to consider when we delve into data validation and where it's rooted. And so this definition of data validation comes from a UK guide that's linked in the bottom there. It's simple: the process of checking if something satisfies certain criteria. So that's what I like about it, the simplicity. And at first glance, it's covering the quality of the data. That's the something that's here. And again, there's all sorts of ways of attempting to increase the likelihood that you're going to get good data. But if we go back to those relationships, where does that something, that data come from? And that's what fascinates me with this particular topic. And it usually starts with the researchers, right, who put out the call for the need for data, and they create the criteria or the expectations that they have that comes from their scientific community. And remember, the data has to be able to confidently answer some real world question, because the researchers are supposed to be trying to publish, or try to share that information. So that something, that data, is also then collected by volunteers or citizen scientists. And so that's one representation in my mind of that relationship between researchers and the public in citizen science. And validation, for me, I see it as every bit as much about trust as it is about quantifying the quality or the reliability of data. And now I've only been involved with citizen science since 2013, when I trekked out here from New York State. So I am not native to Nebraska. And I've always been interested in the educational and behavioral and social outcomes of citizen science. What I can say is that a decade ago, the literature about citizen science was heavy on the side of researcher outcomes. And I think this really reflected the concern surrounding whether or not citizen science data can be trusted for policy decisions, like we discussed in the panel, for publications, for the scientific literature. And I think that's still the concern today. But I do think that because of this concern over the past several years, there's a nice paper trail. There is really a big fat pile of research. I have the folders down here at my feet about data validation that we can look back on and we can reference and benefit from. And so there's also a lot of experience from program leaders on when and how to validate data that's built up over these years, I think, as well. So some of this has resulted in guides and manuals, some that I'll share in this presentation. There are templates and other resources out there on how to determine and strengthen the quality of the data that you have. But before we go on, I just want to go back to this one more time. Again, data validation. So making sure that the data collected satisfies certain criteria. It could be seen, sometimes it is seen, as a power play by some on the part of the researchers. And validation of data, it really shouldn't be just about researchers trusting the data that's collected from volunteers and that it meets certain criteria. The way I construct it and how I'm going to approach it in this presentation is that it's really making good on researchers' promise to volunteers that the data that they've collected and basically the time that they've volunteered is good enough for whatever the project's goals are. So if you're a project leader and you're recruiting and essentially promising that the citizen scientist efforts are going to help solve a problem or result in, published papers. Putting practices into place is important so that their time isn't wasted. And it's showing, I think, that citizen scientists can trust us too. So data validation then, where does it start? It really starts at the end with your outcomes. So for those of you that are educators, you're probably familiar with the practice of backwards design. So it's just like that. You start with your outcomes and you design back from there so that you can create whatever the experience is, but really target the results that you want. And the same idea is used for data validation. So you start with what the purpose of the project is. And the EPA has a great series of guides on this that I strongly recommend you go to and reference. And it's about quality assurance and documentation. And so they provide project outcomes in 3 different categories. So those projects whose purpose is community engagement, they're going to use data for increasing public understanding. Those projects whose purpose is, to do studies, do research, come up with environmental condition indicators. Their data is going to be used for actual scientific studies, publications, and research. And then for those studies that the project's purpose is to inform regulatory decisions, that data is going to be used for legal and policy action. And so this is important to consider when you're figuring out how you want to validate or check the quality of your data, because obviously if the project's purpose is community engagement, the level of checking and quality checking and the stringency of how you approach that is going to be very different than if you're using the data for informing legal and policy actions. Right? It won't be as heavy in a project that's maybe focused on public understanding than the ones that are actually going to inform regulatory decisions. So data validation, again, is the process of checking if something, the data meets certain criteria. And in these EPA guides, they really propose it as data quality. All right. So I've always heard the term data validation as like, do you check that the data is good? But really, if you dig into it a little bit more, that's really a data quality concern. And so in those EPA guides, you'll see, and I'll use this for reference, they refer to data verification and data validation. And so they see that as 2 very separate things. And so verification is making sure the data is collected correctly. So for example, is the equipment that's being used calibrated, or are the identifications that your volunteers are making of species correct? And then on the other side, carried out alongside verification or after would be validation. And that's making sure that the data actually meets the project's needs. So that would involve higher things like training of volunteers, or actually going to sampling locations and assessing them to make sure you're getting at the project's outcomes. So that's a little bit higher level and looking at the data a little differently. One thing I wanted to add in those EPA guides, they had a little note to the reader. Project plan, a QAP. And so the note to the reader, it says, "Dear citizen scientist, although a QAP is an imposing acronym, don't panic. Most of the information in this handbook is common sense, and some of the quality assurance activities included here, some of the suggestions that I make, I think you might be already doing some of the things if you're a program leader to help the quality of the data that you're collecting. But with that spirit in mind, I did want to show briefly that a few years ago when I was working on my dissertation, I did a survey of what programs were out there. And obviously the slices of pie here are yellow because I'm an entomologist and that's what I'm interested in. But citizen science collected or generated data does result in publications. So this data can be trusted, it's possible. And these are some examples of literature in the realm of entomology that all incorporate citizen science generated data. And I am certain that if you went into any of these different areas, you would find examples of that today. Maybe not as much 10 years ago, but I think today it's just becoming more common. It's not unheard of. So one that I wanted to point out was the monarch butterfly migration routes, and there are different here. You know, there's species monitoring, insect pest management, and light trap efficacy. All right, so these were all research papers that had a citizen scientist helping. And the monarch butterfly migration route, I always see that as the poster of how effective citizen science can be. There was a small team tracking monarch butterflies, and there's no way realistically that a research team could collect data across the continent. So they had, you know, ways of checking their data where they were able to tag and map out the migratory route, the transcontinental migratory route of a species. So there's a lot of value in quality data from citizen science. So I have 5 examples that I want to bring up, and hopefully you guys will pick at these more. I'm going to introduce them briefly. But one thing I want to mention is that whether it's using an app or your own eyeballs, you as the program leader or some poor grad student or another expert who's arm you twist, you're going to have to sit down and look things over no matter what. So you can quote me on that. There's all different ways to look at the data and assure the quality, but a lot of times, even if you have a program doing it for you, somebody had to program that. So it does come back to the expert and the amount of time that you have to put into it. So first, this is the one that I see most commonly and I've used in projects would be digital vouchers. So this is where the data records are accompanied with a photograph or audio files or video files. This one, there are a lot of programs out there that use this already. So again, expert review is required. So if somebody turns in a sighting of something, for example, and that's really where you would see this, where species, where people are looking for diversity of organisms or, you know, plant or animal, and they accompany it with this, you're going to have to check that photograph or check that audio file. I've seen audio files used for bird calls. You know, you may not see the bird, but you record the call, and so you can track the presence of that species. Or a video file. You know, we have one of our panelists mentioned that would be, well, I guess that would be an audio file. Fireflies would be an example of an audio file where people take recordings of the flash patterns and they submit that. So the data record is the sighting, but the validation is that digital voucher, whatever that file is. Some other projects I've seen this in are Milkweed Watch. The Lost Ladybug project also has, you know, it's very photo, they're often photo oriented. And then we certainly use that for Tick Tag Go. So if somebody says, you know, they found a tick, ticks can be confused with a lot of different things. So that photograph allows us to go check that record and say, okay, yes, this was actually a tick found in this location. And then if we're lucky, this is the species. So some of the considerations with this would be the review process. It can take a lot of time to validate using digital vouchers. There are some programs that help with that, like iNaturalist. And then also the file storage, how you want to collect this information from people and store it. So looking into that beforehand so that it's manageable if it's you or a small team of researchers that are going to go in and check the data records with these vouchers that have been turned in is something you want to consider beforehand. And I think looking at other projects and how they do it is probably a great place to start with that. Another way to validate or verify, if you will, data that's turned in would be specimen vouchers. So this is where the data records are accompanied with actual specimens. So again, that expert review is required. Those specimens are getting sent to somebody. And some examples of projects that do that would be the University of Florida's backyard bark beetles. I actually participated in this project, and so I would put up my bark beetle trap. And I would send them little baggies with the bark beetles. I would send it in the mail. And so they would do I had the data record for where I was in Lincoln, but they would do the species identification. Even if I guessed, they would let me know if I was correct. The Purist project, which focuses on cabbage whites, is another example where you actually send in butterflies that you capture. And then in Tick Tag Go, we kind of dabble with specimen vouchers. Because sometimes the photographs don't always work depending on what kind of animal you're working with. So sometimes we ask people if they've saved the tick. A lot of times people are getting more accustomed to freezing things. So they may save it, and we ask them to send it in so that we can more accurately identify the species and then tie that data record to wherever it is that they collected it. So some considerations for this type of data validation would be the mailing process and funds. If people are going to send it in, do you want to cover that? You might get more vouchers. You might get more specimens if you are able to cover the cost of shipping things. But also, you know, it depends on the project and what people's motivations are. People might be fine sending in a small package with a sample, whatever that sample is. And then also storing the samples. Sometimes a project can be too successful. And I've seen that occur with tick projects in particular, where people were given the opportunity to send in their samples, and then the researchers were completely overwhelmed. They got thousands of samples. So now they have to figure out a place to store them and get through all of those specimens. So those are some things to consider if you're actually receiving specimens to validate your data. Another example I wanted to bring up is a SMART filter. And this was brought up in this particular paper, Data Validation and Citizen Science, a case study from Project Feeder Watch. And so they actually had software that they were able to create, but for monitoring birds throughout the country, they created checklists of allowable species in different geographical areas. And so then when a citizen scientist would submit a data record, if the species was not on that list for that area, that data record was flagged. And so the first flagging was an error message where they could, the citizen scientist could confirm or correct the species that they were trying to enter. But if they insist, you know, that like, no, this is definitely what I saw, if the data is confirmed by the citizen scientist or by the volunteer, that data point still gets flagged. So again, here comes that expert for review. So the expert goes in, and it's quite possible that the volunteer did see something. What I like about this is that it allows for new records. And I think that's one thing that I wanted to bring up here, that it's important to be cognizant of. We know species are moving, and we know things, you know, it doesn't necessarily have to just be animals and plants, but things can change in the environment. So if you're too strict on what your checklist, your criteria are of what is found in an area, you could cut out new discovery. So what I like about the SMART filter is how it does allow for new records to be discovered, and it gives a path for that to occur. I'm just checking my time. So I'm going to move along here. I think I'm yapping long here. The other example would be crowdsourcing, and this is basically a community agreement with identification. So this increases quality. It's used in different kinds of programs, different research programs, but also iNaturalist can help do this for you, where they generate research grade identifications, and it depends on how many people have come to agree on the identification of a particular species. So we use that by default in TIC-TAG-Go, since we are, I'm just bringing up my chat here, since we are using iNaturalist. So some considerations would be what motivates community agreement, because sometimes people may just agree with what they're seeing. So are people actually checking and coming up with their own decision? And then community size, do you have enough people to really get enough identifications on a particular data point? And then the last one would be training and testing. So this training can be a prerequisite for data acceptance. It can be done in person, it can be done online, and it also gives you the opportunity to test skills or abilities. So this one has a lot of time, and it can be monetary input as well. But really, do citizen scientists learn any different than scientists? No. So with a little bit of training, you can give them the skills and help them develop those skills, and then just assess it. And then if people are passing the criteria in the test or showing the skills that you need, you can accept data from that person. They've shown that they are producing quality data. I wanted to touch on this just briefly. We do get a lot of citizen scientists who are researchers. These are the demographics of some of the projects that I've been involved with. So When it comes to trusting data, I think it's important to collect some demographic data. And then also if you're testing skills or identification skills, you can figure out what age groups maybe are associated with quality data. That's another way of approaching the training and assessment. So in the few minutes that I have left here, there are a couple of recommended resources that I want to share. First, networking. If you're in Nebraska, I would strongly encourage you to connect with the citizen scientists of Nebraska, because really what we're trying to do is bring program leaders together as well as citizen scientists so we can learn from each other. If you're struggling with data validation, you're not alone. There are other program leaders that are doing the same. And so we can work together to try to problem solve, because how you test or confirm the quality of your data is going to be very unique. So leveraging some of the communication platforms through this network would be valuable. I would say take advantage of experts in data validation. It just so happens that there's a researcher here who's published on data validation at UNO. I tried to get her for this presentation, but she wasn't available, so you got stuck with me. But these two papers are ones that I've referenced for this presentation. And then also, I would recommend becoming a citizen scientist if you have the time. So experiencing how data is validated and what you're asked to do, I think gives you a good perspective on what you can expect your volunteers to do as well, and help you brainstorm. I think that's one of the things. I have dabbled in being a citizen scientist myself. A great place to find different types of projects would be scistarter.com. So it's an online database of different projects. And I just saw that, yes, I will share the links. I have a Word doc, so I'm going to throw everything in there. And so to conclude, I'm running a little over here, sorry. Citizen science quality concerns have been researched for a long time. They've been a concern, and so they've been researched. And so there is this, you know, these are just the insect ones that I keep on hand for how people have gone through and validated their data. So there's a lot of resources out there and a lot of lessons learned that we can leverage, or you can leverage when validating your own data. And so leverage those experiences from others, the research and the guidelines that are out there to increase the trust and confidence between all members in a project, between you and your researchers, and vice versa. So this is my contact information if anybody's interested. And then I will open the floor to questions. Sarah?
Okay, thank you so much. I'm going to stop